So this is the solution video for the review for quadratic. Because the process is so much the same, I'm going to just pick two of them. I'm going to do number 1 and number 3. I think maybe because they're a couple of the harder ones. So to do these graphs, we're going to do these solutions in steps. The first step will be to figure out what A, B, and C are for each problem. So A is the number next to x squared, it's a 1. B is the number next to x, it's a 1 also. And C is the number without a variable, which is -2. Step number 2 is to determine whether the graph opens upward or downward. In this case, it's going to open upward because A is positive. If A were negative, it would open downward. So this one is positive, our graph will open upward, like that. Step number 3 is the axis of symmetry. This is where you're going to draw a vertical dashed line like this on your graph. So you need to figure out how to do that. Since it's vertical, it's going to have an equation that says x equals something. And the formula for it, the calculator, is -b over 2a. So I'm going to use the numbers that I was given, or that I came up with up here, and say, all right, -b. Well, b, the formula has a negative in it, and then b is 1. So I would, every time I substitute, I would stick it in parentheses, even if sometimes it's not necessary. 2 here for the formula, and then a was also 1. So what I'm going to get on the top is a -1, and on the bottom, 2 times 1 is 2. So I get x equals -1/2. And you can use the fraction if you'd like, or you can change it to a decimal, which is -0.5. So for my purposes, I think I'm going to go with a decimal, although, and again, it doesn't really matter. So what this tells us is I'm going to be putting a vertical dashed line where x is -0.5. But I'm going to hold off on my graph until I get down to step 5, because it really helps to wait a minute and graph some of these things all at once. Step number 4 is called the vertex. This is the point where the center of the parabola is, so sort of right here at the bottom. One thing that's nice is it's always going to show up on that vertical dashed line. But the key was it's a point, so it's going to have a coordinate point, just like this. And what's nice about it is our x-coordinate is this -0.5. Now we have to figure out what y is. So to get y, we're just going to take our answer for x and substitute it into this function and see what we get as an answer. So again, in parentheses, I'm going to put -0.5 and then squared plus, again in parentheses, -0.5 and then -2. So all I did was substitute the -0.5 into the expression so that I can get an answer for it. If you type that exactly how it is on the calculator, it's probably the fastest way, especially with a decimal, but you'll get an answer that is -2.25. So that's what I'm going to put right here for y, -2.25. I'm going to erase that so I have something. And finally, the last step before we start graphing, step number 5, is to find a y-intercept. The rule for this is the y-intercept just equals c. So our y-intercept will be -2. Okay, I think I've got enough stuff here to start graphing it. So I'm going to go ahead and bring up a graphing grid and make myself an x and y axis. Just by looking at this, I think that since I know the graph is going to go up, and this is my center point, the very bottom point, it's no lower than -2.25, so I'm going to make most of my graph in the upward direction here. But for now, I'm going to put a horizontal line right here, and a vertical line right here. Now it's time to plot some points. So let's deal with step 3 first. Step 3 was a vertical dashed line. And where do I need to put the vertical dashed line? Well, where x is -0.5. So that's going to be right here. And here, where x is negative 0.5. Just like that. So that's going to be our dividing line for our graph. That's the center line, or what's called the axis of symmetry. Right now, I want to start plotting some points on here. So this first point is the center point, the vertex. It's over negative 0.5 and down 2.25. Here's down 1, here's down 2. Down 2.5 will be right in the middle, so this is somewhere right in here. That's my center point. So I know now that my parabola is going to go upwards here and here. So let's put the y-intercept on the graph where y is negative 2. Boy, it's really close to where our other one was, but here's where y is negative 2. So what you can see out of this is that you're starting to make the right arm of your parabola. So what that means is you need to find one more point. This would be step 6 for our graph. We need to find one more point over here somewhere to help shape our graph. So if you can think of it this way, I'm going to bring up a little box here that I'm going to try to make look like a ruler for you. So we'll pretend this is a big ruler. If you could look at it like this, okay, right now my first point is at negative 0.5, and then I move to the right. Okay, again, this is at x is negative 0.5, right? This is negative 0.5 on the x-axis. So then I move over. Now my ruler is sitting on 0 on the x-axis. So I want to find another point to the right, though, one more. So I'm just going to move it over. Where should I put it? Well, how about right here on this line? That's where x is 1 on the x-axis. So I'm going to choose x equals 1 and try to find a point on this line somewhere. I'm going to come back over here and do step 6. I'm going to say I'm choosing x equals 1. And I know I'm going to get a coordinate. It's going to be 1 comma something. So how do you think I figure out this something right here? Well, basically, just like I did this one, I'm going to stick that 1 into this expression and try to get an answer for it. So I'm just writing out that expression with 1 substituted in. You can use a calculator, or I think this one is pretty easy. You're going to get 0 as your answer. So it's 1 comma 0. So I'm going to go over to my graph, and I'm going to plot the point to the right one and up 0, right here. So you can see now that I have a curve over here. Well, I'm almost done, because basically all I have to do is reflect these points over our symmetry line so that we have another point on the exact opposite side. I'm going to do those in blue so you know that I got them from reflection. I have one right here on the opposite side of this one. And I have one, this is one block and another half, so it's going to be right in here for the other one. So we have our parabola. Now it's time to draw it in. Just going to connect the dots with a curve. So when you get to this point, now as you've got your whole graph made, the last thing you have to answer is what is the maximum and minimum for these graphs. The maximum is as high as it ever goes on the y-axis. And if you notice, I drew arrows on the end of these to indicate that it keeps going forever. The way we say forever in math is an infinity symbol. For the minimum, you want to know how low does this thing go on the y-axis. If you look at it, this graph never gets lower than right here on the y-axis. That's as far down as it goes. That was at negative 2.25. So this is kind of the work I would want to see to get one of these things totally correct. And by the way, this one's probably one of the more difficult ones because you have decimals and stuff in here, or fractions in there, which makes it more of a pain to deal with, maybe a slight bit longer calculator. So I'd say if you got this one right, well, give yourself a nice good job. All right, let's go on to the next one. I hope you like goats yelling as much as I do. So we're going to follow the same exact procedure for this one as we did for the last one. So step one would be to find A. A is 0.5, B -2, and C -4. Step two was to say whether it's going to be upward or downward. Again, A is positive, so we're going to have another upward shaped graph. Step three, to find our axis of symmetry, our vertical dashed line, right? Find this. Where does it go? Again, -b over 2a. So for us, it will be a negative from the formula, and then b itself is -2. And then here, 2 times a is 0.5. So I got two negatives up here. That makes this a +2, and 2 times 0.5 is actually 1. So I get 2 as an answer. So x equals 2. All right, let's go to step 4, find the vertex point. So we use this for x. Now let's go to the equation and stick in 2 into that. So it's going to be 0.5 times 2 squared minus 2 times 2 minus 4. So if we work this one out, again, you can use the calculator if you'd like. 2 squared is 4 times 0.5 makes this equal to 2. -2 times 2 is -4, and I have -4 on the end. So basically I've got 2 minus 4 minus 4, I get -6. So that'll be the first point that we plot, the center point or vertex. Number 5. Number 5 is the y-intercept, which is just equal to c, and c was -4. So again, we can go ahead and put this on a graph, and we'll figure out on one more point, and we're almost done. Again, let's make a little x and y axis here. This one I've got to get all the way down to -6 on it, so I'm going to leave myself a little bit of space when I make this one. And so the first thing I'm going to graph is the axis of symmetry, which was at x equals 2. So I'm over here where x is 2. All along this line. First point I'll plot is the vertex. In step 4, 2, -6, over 2 and down 6. All the way down here. And the y-intercept, step 5, is at -4 on the y-axis right there. So this time you can see my arm is going up to the left this way. So I had a point where x is 0 right here. I have another one where x is, or excuse me, I had a point where x is 2 right here. Then I had one on the line where x is 0. So I'm just going to go 1 over here and try to find a point on this line somewhere, which would be x is -1. So in this case, I'm going to choose step 6. This time I'm going to choose x equals -1. So I'll have this for x. I'm going to put -1 into my equation. See what I get as an answer. Well, let's see, this time we have -1 squared, which is 1 times 0.5, so 0.5. This comes out to be a +2 minus 4. So in the end, I think I'm going to get -1.5 for that. This one is -1, -1.5. So I'll plot that point. Over 1 and down 1.5 would be right here. Now I'm just going to do some reflections on the other side of the graph so that I can shape it out. So let's see, this time I've got this one 2 blocks away right here. And this one I'm actually going to run off the graph a little bit, so I'm going to change the color here so you can see it. But this one is 1, 2, 3 blocks away from the line. So I'm going to go this way, 3 blocks is 1, 2, probably about right here, where that third point is. So I'm going to go ahead and draw in my graph. Connecting them with the curve. And the last thing I'll enter is my max and min. Once again, you can see it goes totally upward forever, so the max will be a positive infinity. And the minimum, how far down does it go on the y-axis? Down to here. That's where y is -6. So just a few other things about these. If you happen to get one that is upside down, where the graph opens downwards, that means the minimum will go to infinity. In other words, the minimum will be negative infinity, and the maximum would have an actual height to it. So basically, your procedure for these is always the same. Always the same steps to graphing it. When you get to step 6, you need to have graph 3, 4, and 5 so that you can see what point you want to choose so that you can shape your graph using step 6. All right, that's it for the quadratic question.